is Francis, and I'm a cybersecurity from BSU Year 2. So, I'm here today to give you a walkthrough of my simple Python script where we use linear regression to predict housing prices based on the number of bedrooms. And I'll explain the code, the steps involved, and the insights we can gather from the results. So, the step one we did is importing the libraries, where we start by importing the necessary libraries that we can use, which are these ones. We have uh, NumPy and Pandas for data manipulation, Matplotlib for visualization, and Skikit Learn for building and evaluating the regression model. Next step we did is uh, loading the data set, where we load the dataset using pandas. Here we assume that the dataset is named USA Housing Dataset.csv and contains features like the number of bedrooms and housing prices and etc. As you can see here, we have all the values on the dataset and we assume that it is the name of the file. After that, step three we did is selecting the features and the target, where we identify the bedroom as the feature which we will use to predict price, which is the target variable right here. After that, we use splitting the data to split the data into training and testing sets using 80 to 20 split. This is to ensure that we can evaluate the model's performance on unseen data. It means that some data are unseen and some data are seen. So it is this functions means that it will select the seen data only and not the unseen ones. For step 5, training the linear regression model. Next, we create the instance of the linear regression class and train it using the training data. Step 6, making predictions using the trained model. We make predictions on test data. So that's this part right here. That's this part right here. And after that, we that's this part right here. So after that, calculating the performance metrics, that is where everything gets complicated. It is where we then evaluate the model using performance metrics. This includes um, the mean absolute error or the MAE, which is the average error in price prediction. We have mean squared error or the MSE, the squared difference between actual values and predicted values. We have root mean squared error or the RMSE, which is the square root of MSE, which also shows the errors in the same unit as the target value. And lastly, target variable. And lastly, we have R squared value. It is where how well the model explains the variability in the data. So that's this whole thing right here. It is needed to see the prices and calculate all the things that the graph says. Next up is printing the results. This is where this part comes in. This is all for the graphs. Uh, in printing the results, here are the results, which you can see here. We printed out already. One sec. There you go. As it prints the results, it brings out the whole calculations, the whole metric calculations, as well as the graph that we calculated. But we will head on to this after I talk about the decision tree regression too. Uh, so moving on, the model coefficients and the intercepts shows how bedrooms influence price, and MAE, MSE, and RMSE gives insight into prediction errors. And for R squared, it indicates the goodness of the fit. And lastly, last step for linear regression, visualizing and results. Finally, we visualize the results using a scatter plot and actual data points and regression line. Uh, we also highlight residuals, which are the differences between actual and predicted prices. And to conclude this linear regression, we built a simple linear regression model to predict housing prices based on the number of bedrooms. And the results showed that while the model explains part of the variability in prices, there's still a room for improvement, which could be achieved by incorporating more features or trying more complex models. And moving on to decision tree regression, uh, we first have the first two of decision tree regression, the same thing as which is the same thing as linear regression, where we imported the necessary libraries, and we assume that USA housing dataset.csv is the file that we need. So moving on to step three for decision tree regression, the visualizing and decision tree regression. Here we defined a function called um, excuse uh, function called visualize tree regression to compare the performances of decision tree regression models with different maximum depth values. Uh, Function takes three inputs, which are x, y, and max depth. X is the feature data, y is the target variable, and a max depth is a list of depth values to test different levels of model's complexity. For step 4, looping, this one, looping through max depths uh, values. Inside the function, we iterate through the given max depths values, train a decision tree regressor for each, and stores the results as a deep tree can capture more complexity but risking overfitting. So that's not good. For step 5, we did as well the same thing as the linear regression, uh, but the difference are for each three depths, we calculate the performance metrics to evaluate the model. So it gives off a kind of different values to linear regression. For visualizing predictions, we visualize the data. We visualize the data. Hold on one sec. Okay, this. Hold on one sec. This one right here. Okay, visualizing predictions. We visualize the data and regression line for each max depth, and scatter plot shows the actual data points, while the regression lines illustrates the model's fit at different tree depths. For displaying the results, for each depth value, we print the corresponding metrics, which we have here as well. Hold on, let me run it again. Close this graph and then run it again. And it shows this graph as well as this results right here. As you can see, it has two results for max depth equals 2 and max depth equals 5. And this is the graph for visualization. So for each depth value, we print the corresponding metrics including MAE, MSE, RMSE, and R squared. It helps us understand the trade-off between model complexity and performances. For final plot customization, uh, here, which you can see here, this one, this one, this one. Finally, we add labels and a title and a legend to the plot for better clarity and display it to the visualized results, which is these and this and also this, just for clarity. And yeah, so moving on to the conclusion for decision tree regression. This script demonstrates how decision tree regression can model relationship between features and target variables. The result shows how increasing the tree depths improves fit to the data, but might overfit the training set if the depth is too high. By visualizing the regression lines and comparing metrics, we can select the appropriate tree depths and the balanced model complexity and prediction accuracy.